Okay, so on these ones, you are supposed to be um, finding a lot of different information about this. And so a lot of this unit is on domain and range. And so when we talk about domain, we're really saying what are the possible inputs we can put in for x. So domain are the possible x or the possible input values. And the range are the values we get out. When we put in the domain. So when we put in values for x. It's not always x, but just so that you can kind of think about it. So when we put in values for our domain. So on this first one, we have this, says Fred is employed making storage boxes from aluminum sheeting. So imagine this whole thing, 72 inches by 48 inches, is the aluminum sheeting. It says the plate will have the corners cut out in a square, so it's going to look like this afterwards, and then fold it into an open face box like this, and then someone else will attach a lid later. So we've got it going from here, we cut out the corners, we go to the middle one, and then we fold it up and we get to the end. So the first question is, what is the biggest value that x could represent? Well, these little pieces are x's, okay? And so if I'm cutting out these chunks, for this problem, this value of x could not be more, so think about this, this is 48 inches wide. And I'm cutting out x from here, and I'm cutting out a chunk from here. So just think about it, if, say, this were 10, I would be cutting out 20 inches. Well, what happens if I decide to take out 25 inches from each of them? And you're like, well, 25 and 25 is 50. Well, I can't take out 50. I only have 48 inches to begin with, so I cannot take out more than I have to begin with. Okay, so I cannot take out 25. So what I could take out, the maximum value would be 24. And then that would just make a straight line where, so it wouldn't fold up at all. It'd just be a piece of paper. So really, I could take out anything less than 24. So what is the biggest value that x could represent? The biggest value would be really 24, but we're going to say that x has to be less than 24 because we want to be able to fold something up to make a corner. So x has to be less than 24. Now this is a question, what is the maximum volume? This one's pretty tough without a calculator. So I'll show you how to do this on the calculator. First of all, you need to realize that volume equals length times width times height. So if I have the volume of this box, realize this length right here is whatever, it was 72, right? But now it is 72 minus 2x. So volume equals 72 minus 2x. The width, so that's this. It was 48, but we took out 2 x's. If you're wondering why it's 2 x's, because see there's an x here and an x here on this length. And on this width, between these two lines, there are 2 x's that we're cutting out, one from this corner and one from this corner. And then the height is also x. So now what we're going to do is we're going to go to our calculator. And we're going to graph this. And the volume is the output. See how it says V equals? When we plug in these numbers for x, so these are our inputs, when we plug in those numbers, we get an answer out. That's our output. And so our volume is our answer that we're going to get. So when we plug this into the calculator, we're looking for the biggest y value on our calculator because that's the output. So let's go to our calculator. We're going to go to y equals and clear that off. We're going to have parentheses 72 minus 2x times 48 minus 2x times x. Let me just put an x there. And so I'm going to go to second graph. And I'm looking for the biggest value. So I don't want negatives. So I'm going to scroll down. And I know I can't be more than 24. So right around here is my biggest value. So right here it says that it's 9, but we don't know for sure it's right at 9. So let's go ahead and calculate that. So we're going to go to our graph. And when I do this graph, see how it's thinking up here? Well, there's a blue line, but it doesn't show me where my other blue line is. So I am going to zoom out. And I'm going to make it so that my new zoom out, I'm going to move my center to over like here as far as I can. And maybe even up here. So I zoomed out, waiting to see what happens. Oop, there goes one. And here comes the other one. And there's a third one. But I know my maximum somewhere between 0 is right around 9. So here's what we're going to do. We're going to hit second trace, and it brings up the calculate menu. And I want to find the maximum, so I hit 4. Now if you look down here, it says left bound. Well, where do you want your left bound to be? Well, remember we said it was right around 9, so x equals 9. Well, I'm going to move that. I'm going to move that down so that it's 8. And I see this y number, and it's going down, so I hit enter. And it brings up a little line, so it's saying we're looking between, we're going to go to the left of this line. Now it says right bound. And I'm watching the bottom of this screen. Okay? So I'm really watching this y value. And so what I'm watching for that y value to do is I'm watching it to go up. So see how it's going up? Whoops, not anymore. So that's pretty, so 14,581, and it goes to 97, and then it drops down. So I've passed the highest point. So I'm going to go past it one more and hit enter. So now I know I'm looking between these two dotted lines for my maximum, and now it says guess. So I'm going to move this cursor, and I think 97 was about the highest point, and I hit enter. And so it tells me the highest point is at 14,602, and it occurs at 9.42. Okay? So 14,602. So I'm going to write that. So my maximum value is 14,602.37, and the y value, or the x value, is 9.417. So now when I go back to that screen, it'll still be on there. So it says, what is the maximum volume? Well, the maximum volume, let's just round it off. So 14,602. Okay, it's a little bit more, but we're just going to round it to 602. It says if you create an equation for the volume, what would the domain for this situation be? Well, the domain would be all numbers between, so all real numbers between 0 and 24. Okay, that would be the domain. Using the same equation for volume, what would the range be? Remember, the range is the volume. So we could have the volume could be at 0, and the maximum volume was 14,602 and a little bit. Okay. We could just put 0.4, and that'll cover. So it's going to be between these. So that's how we write it one way. The other way we could write it is all reals between 0 and 14,602.4. Okay, so that covers all of those possibilities. So now that's question number 1. So these will speed up towards the end, but right here at the beginning, I'm trying to help you learn about domain and range and what the numbers could be, okay, and the maximum and different things. Now it says identify the range and domain of the following equation. So I have that equation, y equals x squared plus 2x minus 5, and I've drawn it for you. So this one, it's not in a story problem. It's not, we don't have any kind of context. We don't know what values X could be. Could they be negative? Could they be positive? We don't know. So based on this information is all that we have. What values could I plug in for X? Well, we don't know anything different, so we know that we could plug in all real numbers. I could go from any negative number to any positive number. Okay? So that's saying that this thing, man, I could find some point out here, some X value, and it's going to have some point up here that's going to show up on this graph. And I could be way out yonder, and I could come up here, and there'd be some point on that graph. And I could go way out here, and I'd have to go way up there. You know, I'd have to be like way up off the page and like off the whiteboard and out of the room to find where it actually goes up that high, but we'd find a point out here for this X that would be on this graph. Okay, so what numbers could I plug in for X? I could plug in any number I want to. There's nothing to stop me from plugging in any number that I wanted to plug in for X. Okay. Now Y is, on the other hand, the range. If I look at this, what are the possible outcomes that I get when I plug in these X values? Well, I look and I'm like, hey, there's nothing below that. Okay. So I'm looking at this and I'm like, there is nothing below this line. So my range values, 1, 2, 3, 4, 5, 6, are all numbers greater than negative 6. So all real numbers from negative 6 upwards. So really we write it like this, negative 6 to infinity. We're saying that it can equal negative 6, so we actually do have negative 6 as a value, and it keeps going on forever and ever. So all real numbers from negative 6 on, okay? So anyways, that's how we would do that question. So now here we are to question number 3. It says Guzzler owns a truck which has a 24-gallon gas tank. We're assuming that's all the way filled up to the top. You can't get more than 24 gallons in there, okay? Because this truck gets poor gas mileage, Guzzler must fill it up often. Luckily for him, the price of gas is good right now and only cost him $2 a gallon to fill up. We have this function f of x equals 24 of x, which means there's 24 gallons in here, a 24-gallon gas tank, and x is the number of gallons pumped into the truck. And f of x is going to represent the amount he spends. What is a reasonable domain and range for this situation? So the domain, this is the number, remember domain is x, it's the input. So what are we putting in? Well, that's the number of gallons of gas. So the domain is the gallons of gas that we plug in, that we put in, or that we pump out of the tank, you know. So how many gallons of gas could we put in? Well, we could put in from 0 all the way up to 24. So from 0 to 24 gallons, and including 24, okay? From 0 through 24 gallons. If we wrote it this way, we'd write it like this. We could put in 0 or we could put in 24 and all the numbers in between. So our real numbers that go there, the range. Well, the range is, remember, it's what we get out, and it says f of x represents the amount he spends. So how much money could he spend? Well, if he puts in a full 24 gallons, he could spend up to $48. Okay, that's the maximum. If he doesn't put any in, he could spend $0. So the range is from 0, so all real numbers, that little symbol means all real numbers, from 0 to 48, and that's the range. So now if I go to question number 4, it says a May's arm throws a baseball as high into the air as he can. The ball follows a parabolic path as far as the height of the ball is in relation to time, okay? So this is time down here. This is the height going up. So the height goes up, and then the height comes back down as time marches on. So the ball, so each of these little squares are 10 seconds. So it doesn't, not quite 10 seconds. It'd be more like 8. So anyways, it says May's arm throws a baseball as high into the air as he can. The ball follows a parabolic path and reaches a maximum height of 200 feet. And it stays in the air for 8 seconds. The x-axis represents time and the y-axis represents the height of the ball. The equation is this. The path of the ball would look something like the picture shown. Each grid represents 10 seconds on the x-axis and 10 feet on the y-axis. What is a reasonable domain and range for this situation? So again, all that we're really saying is, what is going on here? What are the possible values we can have for the domain? So if I look at this, this is this f of x, that means x is our input. So that's always our input, which means that that is our domain. So when I see this f of x, whatever is in here, so if I would have had f of t, that means this is my input. Okay, and it probably should have been a t because we're using time. Whatever is inside of here, so if I had f of smiley faces are my input. That's what we're going to be plugging numbers in for. This is like our variable. This is what we're going to put numbers in for. So that's always going to be my input. So it means x is my input in this case. So x in this case is time. Well, it doesn't make sense to go backwards in time and be like, well, at -2 seconds, he was catching the ball or he was pulling the ball out of it. No, we don't know what happened 2 seconds ago. We know that at time equals 0, he released the ball. Okay, so the domain is at 0, he released the ball. At 8 seconds, that ball came back down. Okay, that ball is back at ground level. Maybe it went in down below ground level, but we don't know. At 8 seconds, we know it is at ground level. Okay, so the domain is just from 0 to 8. So all the numbers, so all real numbers from 0 to 8 seconds for this situation. Now realize if it wasn't the story problem, that we could have this time going backwards and forwards and we'd have to use it all. But since we know more information, we can say, no, this is only between 0 and 8. The range, it reaches a maximum at 200. So the range is from 0 to 200. So all real numbers, that's not a hashtag, all you guys. Before you guys saw it was a hashtag, it was the pound symbol, which means numbers. So anyways, that's a number sign. Huh, good for you now. Now you've learned something new. So anyways, I'm just being random. Anyways, all real numbers from 0 to 200. I said anyways a lot in that last sentence. Sorry, I'll try not to say it again the rest of the video. So that's our answer for number 4. Number 5 says the equation f of x equals -8x squared plus 12x plus 3 represents the path a diver follows while jumping off a 4-foot board into the pool. What is a reasonable domain for this situation? Hint, set it equal to 0 and use the quadratic formula to solve. Or also look at Desmos. What would be a reasonable set of range values for this situation? Well, let's go to Desmos and find out. Okay. So here we are in the Desmos graphing calculator. We're going to type this equation in. So -8x squared plus 12x plus 3. Grab this and move it down a little bit. So it looks like at 0 seconds, it's right here at 3. So that makes sense because they're on the diving board. You know, right before they come off the diving board, they're at 3 feet height in the air. Maybe it's only really 2 foot high diving board, but they pushed it down and then it springs back up. And at 3 feet, their little toes leave the diving board and they're airbound. I don't know. So anyways, just a thought. Oh, I said anyways. So here's the maximum point. 3/4 of a second, 7.5 feet up into the air. And then right here, this person lands in the water. Belly flop, hands first, whatever it is, they touch the water. They're now into the water. and then they go below water, and this doesn't follow the path anymore, but their path in the air looked like this. So they are in the air for 1.718 seconds. So they go from anywhere along this path. So I could be anywhere along this path. So they leave right here. They leave, they're in the air, they reach the top, and then they come down, and then they hit the water. Okay? So that's what we're looking at. So now we'll come back to this picture. Whoops, wrong one. So these values for x, the input values, are 0 to 1.718. So that's the amount of time that this person is in the air. They are at a height of anywhere from 0 to 7.5. So when we go back to our question, so the domain, well, how long is this person in the air? From 0 to 1.718 seconds. That's the domain. The range is from 0 to 7.5 seconds. Okay? Now, it says that we could figure out the domain by setting this equal to 0. So if I did that, this would be A, this would be B, and this would be C, and we would use the quadratic formula. Remember that guy that says negative b plus or minus the square root of b squared minus 4ac all over 2a? And I'd plug these in. I would have negative 12 plus, or let's see, I'm going to use my calculator here in a second. So negative 12 plus or minus the square root of 12 squared minus 4a is negative 8. C is 3 all over 2 times negative 8. So then what I would do is I would come to my calculator. Come on, calculator. Make it so I can see my calculator. And I would come to the main screen, and I'd go parentheses, negative 12 plus second square root, 12 squared minus 4 times negative 8 times 3, come out of my square root, close my parentheses. So this is all the stuff on top, divided by parentheses 2 times negative 8. And I would hit enter. It tells me negative 2.18 is where, so if I looked at this graph, that's where it crosses over here on the left, negative 2.18. Okay, so now I go back to my calculator, I hit second enter. Another little trick is if you hit second left arrow, it puts it all the way back to the left. And I'm going to change that to a minus to do the negative case. And now I hit enter. And it crosses at 1.718. So looking at this, 1.718, so my domain is from 0 to 1.718. So that's what we're looking for on that. Oh, good. I thought I had hit stop on the record. So anyways, you guys just heard that big O of me thinking I made a mistake again. So question number 6 says, in preparation to sell his car, Mordalis decides to rent a rug doctor to clean the car's seats and grubby floor. The carpet cleaner costs $30 to rent and comes with cleaning shampoo and all accessories. Each hour that he keeps the machine, he pays $5 more and may only keep the machine for a maximum of 36 hours. What is a reasonable domain and range for this situation? What is the maximum amount of dollars he could spend? So thinking about this, he can keep this for a maximum of 36 hours. So we could come up with an equation to model this. So really the equation would be f of x, or f of t, because we're going to put time in, equals $5 for every hour, right? So t is in hours. So each hour that he keeps the machine, he pays $5 more, but he pays fee of $30 right to begin with. Okay, so the domain, well, he could have 0 hours on the machine. He could take the machine out of this store and not use it at all. He could just take it, let it sit at home, and not use it, and the machine would have 0 hours on it, but he would still pay $30 because he took the machine out. So the domain is he could have it from 0 hours, but it says he has a maximum of 36 hours. So the maximum amount of hours he could have is 36. So he could have anywhere from 0 to 36 hours. From 0 to 36 hours. The range, well, that's going to be the amount of money that he spends. The smallest amount of money that he spends taking that rug doctor out is $30. So the lowest amount he's going to spend is $30. So it's going to be from $30 to, if he keeps it the maximum amount of time, that's $36 or 36 hours. So 36 times 5, 6 times 5 is 30, carry the 3, 15. So that's $180 plus this 30. So 0, 1, $210. So he's going to spend anywhere from $30 to $210. Okay, so if he runs that machine for 36 hours straight, he's going to spend $310. Or if he keeps the machine and doesn't even run it, but has that machine and keeps it for 36 hours, he's going to be charged for it. So from $30 to $210 is our range. What is the maximum amount of dollars he could spend? Well, that's the 210. Now on question number 7. So 2x minus 3, if we graph that, well, let's graph it so you guys can see it. Let's go to Desmos. And then I'll show you on the other one as well. Desmos, let's clear this off. Absolute value, 2x minus 3. So there it is. 1.5 is the x value right here, and 0 is the y value. But it shows that this thing never goes below 0. But it shows this thing, man, I could take this a dot along here, and I could go for as far left as I want to. You know, if I make this thing smaller and smaller and smaller and smaller and smaller and smaller and smaller, these are still going. I could do this forever, and this would still go to the left and still go to the right. Okay, so how far left and how far right is this thing going to go? Forever. So what values of x could I plug in? I could plug in every value of x that I would like to. Okay, there's no shortage of values of x that I could plug in. So the domain is from negative infinity to positive infinity, or we could say all real numbers. And that would be this little symbol. The range, on the other hand, when we looked at this, let's type it in here just for fun, so you guys can see this, see how they both work. Y equals math number abs 2x minus 3. Second graph. Whoops, graph. Oh, I'm still way zoomed out. But anyways, you can see it doesn't go below here. So I'm going to go zoom 6 just to bring it back to my standard graph. But see, it doesn't drop below 0. So the range never goes below 0. So now when I'm answering this question, it says, what's the range value? It is 0 to positive infinity. In other words, all real numbers greater than or equal to 0. Or we could say y is greater than or equal to 0, or like this. Whatever way makes you happy, those are all correct. Oops, that's this one. So, sorry, I wrote those on the wrong spot. Those are for number 7. I'll fix it. Watch this. There you go. Now they're on the right one, and you don't need the arrows. So that's question number 7. Question number 8. Let's go ahead and look at it on a graph. Square root of negative 2x plus 5. So the square root of negative 2x plus 5. So I look at this one, that's at 2.5 and 0, but it never goes to the right of that. And the reason being is we cannot have a negative number inside of here. So negative 2x plus 5, if I plug in like a negative 3, a negative times a negative is a positive, so that works. But if I were to plug in a positive 3, I get negative 6 plus 5, and that gives me negative 1. Well, what number times itself is negative 1? We don't have it, and then we get into these i's, the complex numbers, and it drives you guys nuts. So for this case, when we talk about domain and range, we want the ones that are not our complex numbers. So what values of x are not going to give us negative numbers? So if I look at this calculator on here again, I see that from 2.5 to the left will give me values that work. Anything to the right, it doesn't work, and that's why there's not a picture for it. If we did it on your calculator, so if I come to your calculator and I go y equals, come on, y equals, clear this off, square root negative 2x plus 5. Oh, I didn't clear off the absolute values. It'll still be there, but it'll look kind of funny. So anyways, it looks like this. And if I go to my table, see after 3 it says error because none of those are real values. So when I look at question number 8, what is the domain and range for this function? It's all numbers less than or equal to 2.5. So all real numbers less than or equal to negative 2 to positive 2.5. The range, on the other hand, so when we looked at those, remember the range never went below 0. So the range is from 0 on up forever. So the range is from 0 to infinity. So this is another way to write this. So negative infinity to 2.5. So the range is 0 to infinity, or we say that y is greater than or equal to 0, or all real numbers greater than or equal to 0. So that's what that is. Question 9. So let's graph this. Negative square roots of x plus 3. So negative square root of x plus 3. And then we need to come out of it. Minus plus 5. Plus 5. So here it is. If I move this over and I zoom out, we're going to get an idea of what happens. So realize it doesn't look like this is going down, but it is going down because these numbers are getting bigger. It doesn't ever flatten out. See how it just slowly keeps going down. So I could get to a negative 1,000 eventually. So there's a negative 1,000, but when I do this, that changes to 2,000 and then to 5,000 and then, so see how this is going down, but it's even slower now because these are bigger numbers. but that's like 2,000. So I could get down there. I would just have to go out here a long, long ways. So it is going down. But I just wanted you to see that it's going down all the time. It's just slowly going down. But it does not go above 5. And it does not go to the left of -3. Come on, stay there. Doesn't like that. So it doesn't go left of -3, and it does not go above 5. So when I go to write the domain and range, so the domain, it does not go to the left of -3, but it goes out to the right forever. So all numbers, all real numbers from -3 to infinity. And the range, we said it never goes above 5. So it's -infinity to 5. So all real numbers less than or equal to 5. That is the domain and the range for that function. Question number 10 says, a bike is going to jump over a group of teachers laying down in a row next to each other, elbow next to elbow. The bike follows a path which is parabolic, and because the bike needs to clear all the teachers, it must clear at least 4 feet. So when we do this graph, yes, the bike follows this path, but actually this is going to be a time, a height graph. So down here, this is actually the time, not the distance the bike flies. And this is the height. Okay, so we could have a height and distance, or we could have height and time. So we're doing it in time. So as time goes on, that bike is somewhere along here. So at 0 seconds, it's getting ready to take off. At this many seconds, it has landed. So the bike follows a path which is parabolic, and because the bike needs to clear all the teachers, it must clear at least 4 feet. So somewhere, this highest point has got to be higher than 4. The equation that represents the height of the bike as a function of time is this. What is a realistic domain for this situation? So the domain is from here to here. You know, we know the bike's still going to be going. We know it was going before, and we know it's going after, but we're just after this snapshot of things. So we could do this 2 ways. We can set this equal to 0, and I can take out a t from each of these, and I get -9t plus 14 equals 0. So then I put each factor equal to 0. So I know that at time equals 0, well, that's when, so when we put this equal to 0, remember this is the height. Well, at this point, the height is 0, and at this point, the height is 0. So at time equals 0, so if we come right here, at time equals 0, yeah, that bike's on the ground. It hasn't left the ground yet on this path. But when it lands, this much time has elapsed. So the way we find that is we continue to solve for this one. So I have -9t equals -14 divided by -9. So t equals 14/9. So the height here is 0, but the time is 14/9. So this point right here is 14/9 and 0. The other way we could have done that is come to our calculator, -9t squared, -9t squared plus 14t. So notice I'm using an x for my, instead of a t, because that's the variable that we have. So then I can zoom in a little bit, and I look at this, and 1.556, which if I come here and go 14 divided by 9, 1.556. But looking back at this, does this clear the 4 feet that's required? Yes. does clear 4 feet, and it would be right here at 0.377 seconds and at 1.178 seconds. So anyways, that is, those are the points. So everything above that clears 4 feet. So between that time frame, it clears 4 feet. So going back to our question, so what is a realistic domain for this problem? Between 0 and 14/9. So all real numbers between that and 1.556 or something. What is a realistic range for this? Well, what was the maximum height when we were looking at it? So the maximum height was 5.44. So a realistic range is 0 to 5.44. So all real numbers between 0 and 5.44. So that's that question. And I believe that's the end of the questions. That is the end. So it's a long video. Sorry, a lot of it's explanation along with the problems. So it's notes and problems together. Hopefully you'll take the time to watch it and then do the quiz that goes with it, and you'll get a better understanding of the domain and the range.